Yeah, I can tell. I can still hear you.
You can still hear the bubbling in the back or whatever.
Oh yeah.
You guys hear that all the time? My aquarium stuff going. You hear the noise?
I can just, I can hear the dry erase board and stuff.
All right, my old ears don't even get all that. Good. Well, hello. Wait for letting folks in here. Put a problem up there for us to start with here.
Hey, by the way, I was looking for yesterday's class posted, and I didn't see it. It wasn't at the top of the list unless it ended up somewhere else.
Uh-oh, I wonder if I did the final step and posted it. Let me go look at that real quick here. Huh. I'm wondering, 19, all right, 20. And let's see what happens if I try something here. All right. Oops. Did not lose my Zoom meeting here.
Don't do that.
Yeah, right. Well, I'll go back and I'm sorry about that. I'll go back and double check the assignment link, and I might have to go back into YouTube and look it up.
Yeah.
Sure.
I just, when I'm doing some of the homework problems, I like to reference it, and I didn't see yesterday's in there.
Doesn't help you much if I don't put it there, does it? I'll fix it though, but thanks for mentioning it. Hello, good morning, folks. Getting most of the group here. I'll get out of the way here. I put one on the board here related to what we did yesterday. See if you can get yourself started by trying to answer that one. Jeremiah was just saying he couldn't find yesterday's recording, your mom, and maybe I didn't post the link. I did all the uploading to YouTube, but I'll check on that later. I think you've got something very similar to this and a mom problem or two. referred to first, second, and third angles. So we're going to try to come up with 3 different expressions that all describe those angles in terms of one of them. Probably the first one is that I would recommend. Call that first angle your X or something like that, and then the others are described in terms of it. And then we need to know that all 3 angles add up to 180 degrees. Add them up. I think getting the 3 expressions, sort of the challenge. So you can put them together, and then hopefully the solving is not too tough. I'll call the first one an X. There, you're getting there. It's working. Sasha, I saw your question just recently, and that's a good one. I'll make up something similar. Follow the same pattern, okay? 5 degrees less than twice the first. Twice the first, 5 degrees less. I want to remember that's subtracting from the other thing. So 5 degrees less. And the third is 10 degrees more than twice the first. So 10 degrees more. Here are the 3 expressions that we're coming up with from the description there. And there are 3 angles in the triangle. Add up to 180. Got that far. The rest was pretty well for you. Put the x's together. Looks like I have 5 x's. Minus 5 plus 10, so plus 5 left. Let's subtract 5. Okay, divide by the 5. I think I got 35. So we'll find the angles to finding all 3 of them. All right, so 2 times minus 5 would be what, 65? And 2 times plus 10 would be 80. And I'll do a little quick math, they do add up to 180. That go okay for you? Let me know if you got lost or can ask some kind of question about it. Hello, Tara. Just worked a warm-up problem here related to angles in a triangle adding up to 180. Okay, should I wait for anybody? Should I erase all that? All right. So here I go. Anyway. Now, Sasha asked me a question, an interest question, percentage question. Maybe it was in the forum and somebody else could answer, but I'm going to make up some other numbers that is similar to what she asked. And let's see, I think it was something like after 5% tax, the bill came to, I'll say, $365. What was the pre-tax bill? I just made up a number, so it's probably going to come out real messy. The answer. All right, but you look at your problem, maybe the tax amount is slightly different, maybe the final total is slightly different, but this process now that I'm going to describe should apply to this. This is one of those where you want to say, well, what percentage of the original does this represent? What percentage did I actually pay? Well, you paid the original bill amount. That's the 100% plus 5% of tax. So this number represents 105% of the original. It's more than the original bill amount. So the 365 is 105%, 1.05 times the original. It's more than 100%. Similar problems have said something like, after a 10% discount, the price is only blah, blah, blah. You know, what was the original price before the discount? Well, in that case, it was 100% minus 10%. So the final was only 90% of the original. You have to think through to what percentage does that number actually represent. So now, dividing by the 1.05, and like I said, I probably turn out kind of messy here. See what happens. See if I get lucky. 365 divided by. Yeah, real messy. Okay. 347 point, we'll call it 62, okay? So that was the original bill. I suppose if you take 5% of that and add it, we're supposed to get to 365. Does that help? Yeah, thank you. Okay, great. How about anybody else? You know, I was thinking, okay, unless you guys keep me busy, this might be a short lesson. You know, we kind of got through most everything yesterday. We'll touch on the Pythagorean theorem problem some more today. But if you don't want me to go over any more, anything else in particular, you know, ask some questions, bring up, we did more of this or that. Let me make sure. Why? Did I push record? Yes, I did. Okay, good. All right. All right, Pythagorean theorem, all right. And it says that if you have a right triangle, I purposely kind of drew it point in the other direction today because that really shouldn't matter. Now we're using A, B, and C. It's almost always C that gets used for the hypotenuse, but it could have been X, Y, Z, anything, letters, right? As long as you remember that that formula places the hypotenuse, right? This one, hypotenuse. That's the one that's always across from the right angle. And those are called the leg. The hypotenuse is always the number that's alone on the other side and then gets squared. Okay, so here's the formula based on this theory, right? And so let me make up examples, right? So how about right? I've got 12 and 5, find the missing side. This is like the first type where, all right, where you know the two legs, find the hypotenuse value. So it doesn't matter, A or B, that doesn't really matter. The legs are just one or the other of those two. Totally arbitrary which one you call which. But, so I'll say 12 squared plus 5 squared. That's what we want to get. Plugging it into the formula. Then, let's see, do the squaring. Each of those get squared separately. Try to add them first. I think I just made a perfect square. Well, you know what? 169 is the square of. You don't have to have all those memorized. Plug that in your calculator. It'd be good practice. Anybody confused so far? All right. Oh, wrong button. I put in 169. I do get 13, right? Square rooting both sides. Something squared, the square root of it goes down to the something. So the C is a 13 in this one, right? A set of Pythagorean triples, 3 whole numbers that work nicely in the problem. Now, I hope mom was careful. If I was writing a test for you or an assignment, if it didn't work out exactly, a nice round number, so to speak, I'd tell you to round it to so many decimal places. I'd give you instructions where to round it off because it didn't work out evenly. Okay. Oh, meant to leave the model up there. How about that one? Kind of finished with one of these yesterday, real quick at the end. It's a tall, skinny right triangle. The orientation doesn't really matter as long as you recognize which side is the hypotenuse, the diagonal. Nice thing about printed programs, the right angles likely to look pretty good, better than what I draw on the board. But in this case, we know the hypotenuse value, and we're looking for one of the legs. I happen to call it an X, call it any letter. All right? So we're going to have one of those missing, and we know the other 2 numbers. Whichever one you want to call it. Let's get the right numbers in the right place. That's the next step. Nice challenge. The next challenge, right? And squaring then. And I think that's 256. I'm pretty sure, but I hate to make a mistake here at this point. Yeah, I got it. Okay, and so now I'm solving for the X, and I've got the extra plus piece I've got to subtract this time. And let's see, what is that? 7? 207? Yeah. So if I square root, looking at the equation, if I square root both sides of the equation, I'm doing the same thing to both sides, makes it a legal operation. So what I'm after is this square root of this number, and let's round that to 2 decimals, okay? See what you come up with. Yeah, let's be sure we all agree on where to round that, what to come up with as a final rounded answer. I got 14 point stuff. What's the last digit going to be? I got 0.387. So the 7 says we're going up. Okay. Light on the dot there. And again, be careful of the context of a problem. That might be like a word problem. They might describe all, you should have some length, some units. Abstractly, it works just the way we're doing it. But if they're feet, make sure you put feet on it or something like that, units for that problem. If you're looking at your homework, right, for this section, I'm seeing a problem relating to a a TV set, right? Somebody goes to buy a TV, and how large is your current TV? Well, and the guy says, oh, it's 26 by 35. Your numbers might be different in this problem. Right? And the clerk says, well, TVs are measured diagonally. That is true, have been for years. And so, same as the case with your laptop. So, what size is your TV? Oh, you got to be prepared to tell them the diagonal distance. So you need to recognize this is just a Pythagorean theorem problem, and we're looking for the hypotenuse value. Okay, the 26 squared plus 35 squared equals whatever. C squared, X squared, whatever. Those would be some big numbers. Good thing we get to use a calculator, right? I'll go ahead and do it. What's 26 squared? 676. And 35 squared. I like that squared button. That squared button. 1225. So now I have to add those together. $1901 is X squared. 90 the square root, both of those, right? How about 43? And inches, right? Of course, it's just a TV, probably not a huge wall screen. Just want to make sure I want to do one within here. Yeah. Any issues for anybody? Okay, I just wanted to point out something about your calculator again. If you're, most of them again have something very similar to this. And, you know, I did all these calculations in my calculator, and then I got up to a point where, all right, I've done the adding, and on my screen, I had the 1901. Like, all right, now I want to do the square root of that number. Rather than completely starting over with the blank screen, what I want to point out is on my little calculator, there's the button down near the equal sign. First of all, what it means, it's got a minus sign in parentheses. Well, that actually allows you to take a number and turn it from positive to negative. Like if I've got, okay, I did all this calculation and now I've got a 35 and I want to subtract it from my other number. If I just touch that key, it makes it negative 35. So it's not quite the same as minus, right? It's not subtracting, it's changing the sign of your number to positive or negative. And above that, the second function says answer. So right now, from this screen, if I push the square root button and it presents me, it'll go right to that. But now I'm going to say second answer, do that button. And it's going to plug in that 1901 for me right away. You know, you might just start, you might practice that. Put something easy on your screen, like, so put on 25 and do your square root and then do that whole second answer. And it'll put that number right inside there for you. So it just saves you some keystrokes. That's all I'm talking about. Saves you some strokes on your calculator. All right. A similar question. Again, looking at, well, there's really kind of only two kinds of things we would ask in this kind of problem. Find the hypotenuse, means you know the other two legs, or find one of the legs, means you know one leg and the hypotenuse. So plugging the numbers in for either a leg value or a hypotenuse value, and then manipulating and eventually square rooting at the end. There's another one I noticed says, oh, you have a 16-inch laptop and the height of the screen is 7 inches. How wide is it? So this is very similar to the TV problem I just did, right? Except we're looking for one of the legs. So you could say x squared plus 7 squared equals 16 squared. Make sure you get those squares on there. That's real unfortunate if you forget to do that. Hey, did we just do these numbers? What did we come up with for that? Is it 13 point something? Yeah, 14.39, that was it. These were just the numbers that came up on the problem, my version of your homework problems. So hopefully that, draw yourself a little picture. Not a bad idea. Most of the time with anything based on a geometric shape, draw yourself a sketch and draw in the dimensions and figure out which one you're looking for. Another one in here. Oh, I think it's about a person who's got their kite stuck up in the tree, and they know they're say 5 feet away from the tree. And let's see, how do they give you that? Oh, duh. And so the kite string, say maybe is 20 feet long. How tall is the tree? How tall is your tree? All right, so it's building a right triangle out of that situation. Kite stuck up at the end of the string, that's your hypotenuse, your diagonal. You know how far you are, there's one of the legs. From that, you can figure out the height of the tree. Let's see. I know that I'm trying to make up another problem I was familiar with, but that has to do with angles, and we're not doing those. More like a geometry problem. All right, your turn. And I've gone through, I think, covered everything in our section here. What should we do more of? I think, can we do more of this or that?
Stephen, there was one on the homework that we were doing that I just wanted to go over again real quick. It was like question number 4.
Is this 3.4?
Yes, this is for 3.4. Question number 4 and 3.4.
Yes. Oh, the isosceles triangle. That sounds right. That one.
Yes.
All right. So I'm going to look at my version of it. I happen to have it right here, and yours might have slightly different numbers. Right. I like that situation here. I can do a model for you, and then you see if you can follow yours. But the longest side of an isosceles triangle, mine says the longest is 7 centimeters less than twice as long as the other side. So isosceles, if you recall, these two are the same. All right. So there are x and x, two are the same, right? And the longest side, mine says 7 centimeters less than twice the others. Not the sum of the others, but just each of those being one of the others. That this one is 7 less than that. Now, does that make sense? Looks like similar to your problem, I hope. And this relationship might be slightly different in your problem, if you're going to get something similar to that. And then it's a perimeter problem. The perimeter is, mine says 109. So those all add up to that total perimeter value. So when you solve for x, you're going to get those two, and then you could do this calculation to find the third side if it wanted it. I think the problem says find the longest side. Oh no, find the lengths, list them in ascending order. Well, two of them are going to be the same, right? So x, x, and then the long one. So here it looks like I would have 4x minus 7. I add 7 to my problem here. Right. Divide by 4. And that's, I think, 100 would be 25, and then another 429. And in this case, centimeters. All right, so then 58 minus 7, 51. Did that help? Do you follow that?
Yes, it helps. Thank you.
Okay. Woo-hoo. How about somebody else? We could almost think like we're reviewing. We're going to do this. We're going to review on Monday. Test is on Tuesday. I hope you kind of looked ahead and saw that coming.
Actually, another question. I know in the past we had the geometric formulas and stuff, and as far as like the Pythagorean theorem, is there like a printout that we can have, or is there something available, you know, that we can have some of those theorems for the test?
Well, the problems on the test.
Oh,
I was going to say the ones that are on the test related to this idea, right? I think you need to know 3 ideas, okay? You need to understand how to find the perimeter of a rectangle. If you're just at, say it's a rectangle and the length is 3 times the width or something like that. You'd understand that formula. Have that one memorized. I hope we've gone over it enough that that makes sense. If we have one of those weird shapes where there's, you know, 1 length and 4 widths, you kind of got to build your own formula, but understanding, adding them up to get the perimeter. But then as far as a formula that you have to know in advance, there isn't something for that. The other one would have to be that in a triangle, right? The angles all add up to 180 degrees, right? You need to know that all 3 angles add up to 180, and then similarly you can talk about the relationship like the one I made up to start with, the relationships between them. And then you do need to know this theorem, whoops, and understand that's the hypotenuse. It's not going to, the problem will not include a bunch of problems based on those other geometric shapes that we did cover. I saw one maybe in a review where it referred to the area of a triangle, but it gave you the formula for the area. If it's that kind of a problem, the formula you'll need would be in the problem. It's like, oh, if you know what the base is, find the height. If you know everything except the base, you could sort of solve that for the height. Hopefully, get all the numbers except h, then you'd be solving that. So maybe that sort of the short answer was no, you don't really get a sheet, but what you need should be there if you understand or if you've got these 3 things memorized here. Okay? Right. You wish there was more. But good question, because We'll kind of make that real clear that yes, there are a few formula-like concepts we kind of expect you to know. And this is just, if you step back and thought about it, you could just think of it, you know, we got this two lengthless, widthless, width. We make that up. Or the perimeter of a triangle is add up all three sides. How about something else from somebody? How about I'm just going to make up one like this, right? Area of a triangle, 1/2 the base times the height. I'm going to make up a couple numbers, so who knows how messy it'll be. Let's say I know the area is 35 square feet, and I know that the base is, say, 5 feet. How high is it? What's the height? If I know the base and I know the overall area, if I plug those all into this formula, 1/2 times 5 times the unknown is an h. I think I saw one of those in one of the review, optional reviews for the test. Just say if you get the week's homework done, I encourage you to get started on working through at least one of those. The second one, that's the printable review, is the one that has answers on the second page. That's kind of nice. But here I would do something like, well, you could do 5/2 and get 5/2 and then do multiply by 2/5. I might do something real step at a time and say, well, what if I multiply both sides by 2? That cancels this out. All right. And then I'm going to divide both sides by 5, and it cancels that out. That's 14. And we were talking about feet, so 14 feet would be the height. Taller than it is wide. I don't think it's made up. But plug it into a formula. How about, here's an idea. Oh, there I go, sorry. Can you solve that formula for h? Something you're going to have to do is rearrange these formulas, solve for one of the letters. It's really all the same steps I just did, except you don't have numbers in there. I was going to solve that formula for h. I'll get this one all alone. You could think of this as, well, dividing by 2 and multiplying by b. So we're going to undo those two things that are affecting the h. Just like I did a minute ago, I probably divide, multiply times 2. What's going on? Multiply both sides by 2. All right, I kind of just canceled the 2, a half out there. Multiply both sides by the 2. And now I'm going to divide both sides by, maybe show that here. Divide both sides by the b, and there it would be. My family moans and groans because I like my puns. Oh, old dad jokes, right? So there, I solved that equation for h, rearranged it. Let's see. Very similar to the one sort of going the opposite direction that Tasha had brought up this morning, where we had added tax, and so we were paying 105% of the original. Here, the price that I'm given is after a discount. So again, what percentage of the original does this number represent? You got to do the little, I mean, I write it out, but a 50% discount means we took 100% and we subtracted 15%. So that price is only 85% of the original. All right, 270 is 0.85 times that original price. I'm going too fast. I keep meaning to make you do it. Hopefully that makes sense. And dividing both sides by the 0.85, you get x alone. What kind of messy number did I make up, all right? Yeah. Oh well. Round to the nearest cent. Pennies. Leave your change. Keep the penny. That's, I say it a lot these days at the store. Keep the penny. Apparently it was a great marketing idea, so we decided $2.99, sell a lot more than $3. Sounds better. I guess it psychologically was a good thing. Nowadays we just keep the penny. We don't want to deal with it. Does that make sense? I just kind of made up a percent problem. I'll kind of do more of this on Monday. I'm prepared to make up a sampling of, solving basic equations. Right? Solve basic all the way to those ones that have lots of parentheses and stuff in it, and simplify. Be able to classify an equation. Is it a contradiction? Is it an identity? Or maybe it's just a normal conditional equation. Solve a formula for one of the values in the formula, like the triangle area formula I did a minute ago. And then we probably get into those things we've been doing in this chapter where one number is 5 less than twice the other and they add up to something or other. And then a Pythagorean theorem problem, at least one in there. Find the hypotenuse or find one of the legs. Anybody else? Otherwise, we might stop early today. Of course, get your homework done, and as always, I'll be glad to reply to questions. Whether you post them on the forum, I might give a hint, or say, I'll wait a minute and see if anybody else chimes in. If you just want to send it to me directly as a message, then I'll get back to you. Monday we'll do more of this. We'll review, and encourage you again to get started on the review assignments. And Tuesday we do it again. We take the test. All right, folks. Well, I'll let you go. You let me go, and have a nice weekend. It's going to get chilly. Nice morning today, right? All right. Goodbye.